Hi, this is Dr. M. Geeta, Triple E Department of Sri Ishwar College of Engineering. I am going to discuss about the architecture of 8086. 8086 is the microprocessor. So it will fetching the instruction from the memory and decode it and execute it. It is unlike microcontroller because it has no memory and peripheral devices inside it. In introduction part, it has 16-bit data bus. 16-bit data bus means maximum 16-bit data can be shared through the bus, and 20-bit address bus, so maximum of 1 megabyte of memory. So 2 power 20 means it will give the 1 megabyte of memory. It is called segmented memory architecture because the memory is divided into segment. Here 1 megabyte of memory is divided into 1664K memory segment. Operated with the clock frequency from 5 to 10 MHz with 5 volt DC supply and support 64K ports and operate in maximum and minimum mode to achieve high performance. And 3 register: general purpose register, segment register, special register. General purpose registers always it is used to store the result of the ALU operation. Segment register where you can access the address of the instruction from the memory segment. Special register we call it flags register and instruction pointer. This is the architecture diagram. The top you have the bus interfacing unit. It has different segment memory and 6 byte prefetch queue and control unit. In execution part, it has general purpose register, ALU, flags. We will see. The function of bus interfacing unit is to fetching the instruction from the memory and rewrite the data into the IO devices. And the function of execution unit is decode the instruction and execute it. The main component of bus interfacing units are instruction queue, segment register, instruction pointer. Instruction queue in order to increase the speed of the microprocessor operation because the 6 instructions is fetching from the memory and it will be stored in the instruction queue where the execution unit fetching the instruction from the queue. And memory segment, there are 4 kind of memory segment. Code segment where all instructions are stored. Stack segment when the subroutine program is called, the current or main program address can be stored there. Data segment where the data will be stored, and extra segment the extra data will be holded. An entire memory of 1 megabyte is divided into 64K memory. In that only 4 segments, we call it code, stack, data, extra. 464K we only use it for memory. In that pictures, the IP, SP, SI, DI is given here. It is used to access the particular memory location from that segment. Instruction pointer, it is a 16-bit register. It holds the 16-bit offset of the next instruction byte in the code segment. Always it will be pointed the code segment. Stack segment register and stack pointer register. Stack segment registers we are use it for the subroutine program, but this stack pointer is always point the top of the stack segment. Execution unit main components are instruction decoder, control system, arithmetic and logical unit, general purpose register, flag register, pointer and index register. Instruction decoder is the function is decoding the instruction, because all instructions which will be stored in the form of hexadecimal, this has to be decoded by this instruction decoder. Control system is main part to provide the necessary timing and control signal for the entire operation of the microprocessor. And ALU unit is, it will do arithmetic, logical and OR and increment, decrement. So all operations can be done by using this unit. And general purpose register, we call it 4 things. So AH, AL, BH, BL, CH, CL, DH, DL individually we used as the 8-bit data accessing. For 16-bit data we call it AX, BX, CX and DX. These are called a 16-bit register, that is L or H defined for 8-bit register. And how instruction affect the flags, we will see here. And some of the instructions will not affect the flags. For example, move, exchange, add, subtract, increment, decrement. Here no flags can be affected. Now we will see what are the flags registers available. Mainly 9 flag registers is available in the 16-bit register. So here it is grouped into 2 categories, conditional flag and control flag. In conditional flag means carry flag, parity flag, auxiliary carry, zero flag, sign flag, overflow flag. Carry flag means the carry is generated from the MSB bit. It may be a 8-bit means 9th bit will be called as carry. If it is 16-bit means 17th bit is called a carry. And parity flag means the result has even number of ones. That time it will be set. Auxiliary carry, here this carry will be set, this carry flag will be set, the borrow or carry from the lowest nibble. For subtraction, borrow will be performed. For addition, carry will be performed. Zero flag, entire result of the ALU operation is 0 means this will be set. And sign flag and overflow flag. Sign flag normally MSB bit, if it is 1 means it is called a negative number. If it is 0 means it is called a positive number. We will see what is overflow flag. Okay. So it will be identified the error in the signed operation. And in the control flags, they are called trap, interrupt flag and direction flag. Sign flag means what? The sign flag is equal to 1 means if the MSB of the result is 1, that is negative. If it is 0 means MSB is 0. Overflow flag means if the signed overflow occurred means it will be 1. We will see here. This is the example which is given here. That is, the instruction is called add AX, BX. That means the data in the BX and AX will be added. For example, 4F. So each F has 4-1. Okay, it is in the form of binary. And these two data called 4F, 4F. If you add these two numbers, the carry will be generated. So what are the flags will be affected here means, here the sign flag, because MSB is 1, it will be affected. Parity flag definitely not, because And parity flag is 0 because there is 7, that is a odd number of 1. Okay, and 0 flag will be set because result is not 0, and carry flag will be set because out of MSB, and overflow flag it is 0. I will tell. So what is mean by overflow flags? Okay, this is another example. This is add AX comma BX means you add 16-bit number. Okay, if add AL comma BL means add 8-bit data. And this is for given overflow flag. So when it is set, in that you see 8-bit operation means it should be the range. When you add two assigned number means, if you add two 8-bit data means the range should be minus 128 to plus 127. The overflow flag, okay, will be set if the range is overcome. For 16-bit operation means the range should be minus 32 comma 768 to plus 32 767. Okay, when this range is exceeded, the overflow flag will be set. And next, control flags. It has 3 flags. Okay, the control flags enable or disable certain process or operation of the microprocessor. So it will define the process of the or operation of the microprocessor. So trap flag means, so here the CPU is automatically generate the internal interrupt to inspect the instructions. That is trap. So here it is used for debugging process. When this flag is 0 means no function is performed. Interrupt flag means whenever the peripheral wants to communicate with the microprocessor, this flag will be set. Direction flag means the instruction fetching from the higher memory location to lower memory or lower memory location to higher memory. It will be set. So when it will be set means to access the data, that is string data, from the higher memory location towards the lower memory location means this will be set. Here the two instruction is given, that is jump instruction and compare instruction would affect the flag. Okay, jump instruction means which is called unconditional jump. The address which will be defined short, near and far address. Short address range means limited distance. It will that is transfer the program control to the next location. Okay, that is the short address range is minus 128 to plus 127 byte. Near address means minus 32 768 to 32 767, and far address means it can access the next segment. Now we see the function of jump instruction, how it is performed, how it is affect the flag. And compare instruction, this jump condition is often provided by the compare instruction. Okay, the syntax of compare instruction is CMP destination comma source. So it is the result is not stored but the flags are affected. It will compare the content between the two register. Okay, conditional jump, that is signed jump. Signed jump means when the sign flag is set, the control will be changed or transferred. For example, first symbol is called G, that is jump if the data is greater than. JNLE means if jump if not less than or equal. So the corresponding flags is zero flag is 0 and signed flag is equal to overflow flag means these instructions will be executed. Similarly, JL means jump if less than. J and GE means jump if not greater than or equal. Similarly, unsigned jump means used for unsigned interpretation. That is, when you are dealing with the unsigned number means only carry flag and zero flag will be used. For signed interpretation, you should use the overflow and the sign flag. This is the example. In the following example, JL instruction jump to label 1 because AX is less than 6. So we see move AX comma 5. That means 5 is loaded into AX and compare AX comma 6. 6 will be compared with the 5. Okay. Now what instruction we are going to use? JL. JL means what? Jump if less than. Okay. Here jump if less than because the AX content is less than 6. Thereby the control is transferred to the next locations. Here in the last part of execution unit are pointer and index register. So AX is called 16-bit accumulator which will store the 16-bit result of the ALU operation. AL, it is called 8-bit accumulator, store the 8-bit result of the ALU operation. BX is called base register, used to hold the base value in the base addressing mode to the accessing the memory data. And CX for counter register. For the operation of shift, rotate and loop instruction, it will hold the counter. DX data register, it is hold the data for multiplication and division operation. Stack pointer, base pointer, source index, destination index are called the index register. Stack pointer, it will hold the offset address of the stack memory. Base pointer, it will hold the specific locations of the stack memory. Source index, it will hold the source operand for the string instruction in the data. Okay, and the data segment. Same in the extra segment, it will hold the index of the destination operand for the string operation by means of the data index. Normally, the source index always pointed to the data segment and DI will point to the extra segment. Finally, we are calculating the physical address. Here we call it 4 segments. And default registers, offset registers is given here. Normally, each segment will hold the 16-bit data. But how to calculate the physical address means physical address having the 50 to 5F. But the segment has only what? Up to 4. So you should multiply it with the 10. Plus you should add with the offset address. Then you can calculate the physical address. We will see the complete example. And here the segment address is only 4 digit, right? That is 1005, 4 digit. And the offset address is called some other locations in the particular segment. Okay, that is 45H. So segment address in the form of binary, 1 means you should write 0001 and 0 means you should write 40 and again 0 for 40 and 5 for 0101. shifted left by 4 position. Now it should be multiplied with 10, no? So that's why we are adding extra 0 at the appended to the data, binary data, and add with the offset address. Now you should add, then finally you calculating the physical address. Okay, here in the segment address, finally you converted into binary, and end of the binary you should add 40 and add with the offset address, and finally you can calculate the physical address. So I hope this video will give the clear understanding about the architecture of 8086. So thanks for watching.